quadratic equations with complex solutions. The general strategy for solving quadratic equations is you start with it in standard form most of the time, and then you solve it by factoring or square root property. Sometimes you'll have equations that won't factor, or equations that you can't use the square root property on. So you then proceed to the last two methods, quadratic formula or completing the square. So let's look at a couple of problems here. The first problem is a pretty simple one. X squared plus 25 equals 0. It's in standard form. We would want to solve this one by using our square root property. We want to use the square root property anytime we have the x squared term, but we don't have x to the first power. So the square root property tells us we need to get our x squared by itself. So we'll subtract 25 from both sides, and that will give us x squared equals negative 25. We don't want x squared, we want x. So to get the x by itself, we undo the square root, we undo the square by taking a square root. But when we take the square root, remember that everything really has two square roots, a positive and a negative. So we end up with a positive and the negative square root of negative 25. Then we can simplify our radical. Because it's a negative, we know it's going to have an I in the answer. And then the square root of 25 is 5. So we end up with a positive or a negative 5i. In this equation, we still want to go through the same steps. We want to get the x squared by itself and then take our square roots. So I'm going to subtract 15 from both sides. So that'll give me 2x squared equals negative 15. So I need to divide by 2. So x squared will equal a negative 15 over 2. Now same story here. I don't want x squared, I want x. So I undo the square by taking the square root. But once again, I have to take both the positive and the negative square root. So I have x is equal to a positive or a negative square root of negative 15 over 2. So I know the negative under here is going to give me an I for my answer. But I also have the denominator under a radical. And we never want to leave an answer where the denominator is under a radical. So we need to rationalize this denominator. We multiply the numerator and the denominator by a square root of 2. Because when we do that, that will give us a negative 30 in the numerator, and it gives us a 4 in the denominator. Now both of these are still under a radical. We have the square root of negative 30 on top, and the square root of 4 in the denominator. So the square root of negative 30 just gives us a square root of 30i. And then the square root of 4 is 2. So here we end up with a positive or negative square root of 30 over 2i. Now this equation I can't solve with the square root property. I also can't solve it by factoring. So I'm going to start this one out by using my quadratic formula. My A is 2, my B is 5, and my C is also 5. So let me write down the quadratic formula. Remember, if you will write it down every time you use it, it will help you remember it. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So let me put some numbers into this. The opposite of b will be a negative 5. So we have negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 5, because A is 2 and C is 5, all over 2 times A, which is 2 times 2. So let's work this out under the radical. My 5 squared is 25. Then I'm going to have minus 8 times 5, which is minus 40. So that means I have a negative 15 under my radical. And then the 2 times 2 in the denominator gives me 4. So let's see, since there's a negative under the radical, I need to simplify that. So I will simplify that by writing it as the square root of 15 times I. And then because it's got the I in it, it's a complex answer. So I want to write my A term and my BI term as 2 separate parts. So the first part, the real part, will be the negative 5 over 4. And the imaginary part will be the square root of 15 over 4, I. I just put the denominator under each term. So I have negative 5/4 plus or minus the square root of 15/4, I. So this means that both of my solutions to this equation are complex. So if I were to look at the graph of x squared plus 5x plus 5, I would not have any x-intercepts because my discriminant, b squared minus 4ac, was less than 0. The discriminant was this part under the radical. Since it had a negative value, my graph would not have any x-intercepts.